Professor R. Ashokamani, Director, Research and Development, Dhanalakshmi College of Engineering, Tam from Chennai. He is former professor and head of the department, Physics, Anna University, Chennai. He is presently guiding 3 research scholars. He has more than 44 years of UG and PG teaching experience and 33 years of research experience. 14 research scholars have obtained doctorate under his guidance in the area of material science and solid-state physics. He has more than 150 research publications to his credit, of which 90 are in international journals. He has authored a book on solid-state physics, which is an international publication. He has participated in several international conferences, both in India as well as in foreign countries such as USA, UK, France, Germany, Italy, and Yugoslavia. He has been a guest scientist at ICTP, Italy, several times. He is a fellow and treasurer of Tamil Nadu Academy of Sciences.
Welcome to the UGC lecture series. We have been going through a course of lectures on optics, and in this lecture, that is the last lecture in the whole of optics, we have holography, and the contents or principle of holography, uses of lasers, transmission and reflection holograms, recording and reconstruction of holograms, equipment needed, and lastly applications of holography. That with regard to principle of holography, it has made possible to obtain 3-dimensional images of objects using the off-axis arrangements. Generating and viewing hologram is possible and presently used. With regard to principle of holography, again, as I told you, there is one beam which is called the reference beam, which does not interfere with the object, whereas the other one falls on the object, and you have got an animation which clearly shows the principle, wherein you have the laser here, the beam splitter splits the light, one falls on the mirror and comes here directly. It has nothing to do with the object. You look at this ray of light, it is incident on the film, and it has nothing to do with the object. The object is here, whereas the other beam, which is split by the beam splitter, it comes in this direction, falls on a mirror, goes through a lens and falls on the object. What happens here? Here the two beams interfere. This is a beautiful animation which shows the phenomenon of interference is the one that is responsible for obtaining the image of the object. You got the object here on the film. The film is coated with some sort of emulsion. I would like to tell you here that the laser which is used may be helium neon laser or ruby laser or any other laser. Okay, so you have the off-axis arrangement. A broad laser beam is divided into 2 beams. As I told you just now, the reference beam goes directly, whereas the other beam falls on the object and getting scattered, and it falls on the photograph. These 2 waves interfere. The interference is a phenomenon which is very important, that gives rise to the image. The spherical waves from the object combines with the light wave coming from the reference beam. They too interfere with each other. So the interference is the important point. The interference fringes that are obtained on the photographic plate, that gives the what is called these 2 beams are getting superimposed, and a complex pattern of lines and soles are obtained. The developed negative of these interference fringe pattern is a hologram. The developed negative of these interference fringe patterns is a hologram. Thus, a hologram does not contain a distinct image of the object but carries a record of both. A very important point. The intensity and the relative phase of the light waves at each point. Whenever required, the object can be viewed. You have to illuminate the hologram and you can see the image of the object, and again it is a three-dimensional image. Not only that, the image can be seen from all angles to see the three-dimensional thing. For reconstruction of the image of the hologram is illuminated by a parallel beam of again a laser. Most of the light passes straight through, but a complex of fine fringes acts as an elaborate diffraction grating. Therefore, you have interference, diffraction and laser. All these things come into the picture when you are talking about recording and reconstruction. This is a reference wave which I showed you earlier. Okay, this is a reference wave, and this is the real image. This is the real image. This is so-called virtual image one can see by eye, and this shows them how the reconstruction is being made. You see the virtual image by the eye can see from the hologram you can see the image. Okay, this is the real image, this is the virtual image. The image cannot be touched by a human hand and felt. It is a virtual image. Light is diffracted at a fairly wide angle. The diffracted rays form two images, a virtual image and a real image. The virtual image appears at the location formerly occupied by the object and is sometimes called as the true image. The reconstruction of the image, again, the real image is formed in front of the hologram. Since the light rays pass through the point where the real image is, it can be photographed. The virtual image of the hologram is only for viewing. Observer can move to a different position and look around the image to the same extent that he would be able to were he looking directly at the real object. You can look at directly, and as I told you in the last lecture, you can see the image obtained in the film from different angles. This type of hologram is known as a transmission hologram, since the image is seen by looking through it. You are seeing the image through the film. The three-dimensional image is seen suspended in mid-air. It cannot be caught by hand or at a point which corresponds to the position of the real object which is photographed. This is a recording of the hologram. The object is here, the wavefront, CCD, the recording. This is a reconstructed image. You see the reconstructed image. Basic holograms require just a few basic components. I am now talking about the equipment needed to take holograms and to view the holograms. Light source, you need a laser. Different colors of lasers can be used according to the film. As I told you, the lasers of different wavelengths, helium neon laser or the YAG laser, EG laser, all these things can be made use of depending upon what you require. Spatial filter is a combination of an objective lens and a pinhole. The light is focused into a pinpoint by the objective and then passes through the pinhole that creates modes. The basic equipment, as I told you, in continuation what I have been telling you, aperture is closed or open accordingly to select the central mode, which is the bright area in the center of the pattern created by the spatial filter. And you require a film, and the film is made up of certain emulsions, chemical emulsions. Holographic film, like photographic film, uses a chemical emulsion to capture light information. There are a variety of holographic films for different colors of laser light. One of the particular film used is Slavage PFG01, which is red light sensitive. Emulsion undergoes a chemical change when exposed to light, which then is exploited by the developer and fixer. There are two types of holograms. One is called a transmission hologram, wherein you use two beams to create the interference pattern recorded on the film. A beam splitter divides the laser beam into two parts. One becomes the reference beam and the other is the object beam. The reference beam needs only to go to the film. As I showed you, the reference beam goes straight to the film. The other one falls on the object and getting scattered. The reflection hologram is a different kind of thing. It is much cheaper, but it is not as good as what is called a transmission hologram, which is much costlier. Place the film, in this case, place the film between the light source and the object, thus effectively creating two light sources and an interference pattern. The transmission hologram, they take up more space, require more equipment, and it requires more adjustments and fine tuning to acquire a good hologram, a costly process. Reflection, again, the transmission holograms, however, the freedom to adjust many more parameters in a transmission hologram makes them a more powerful tool. This is a very important thing. The freedom to adjust many more parameters in a transmission hologram makes it to be a more powerful tool and also costly. Reflection holograms, they are much simpler to create and require little setup and equipment. They are limited in their ability to change relative intensities and requires transparent film. Current and future applications of holography. As I told you at the beginning, holography is a thing which was invented by Gaber when he was trying to improve the functioning of electron microscopy or electron microscopes. And other important point is, without having a coherent source, he could not achieve what we call today as holograms. As I mentioned, the other physicists were able to make holograms after laser was invented. As I told you, Einstein is rightly called the father of lasers. So, after the invention of laser only, the holograms could be constructed. And as I mentioned just now, there are two kinds of lasers, two kinds of modes. One is called a transmission, the other is called a reflection holograms. A holography, the whole area, is very useful tool in many areas, such as in commerce, scientific research, medicine, industry, defense, biology, and so on, in many other fields as well. You go to supermarket, you give the credit card. So, the credit card, as all of you know, contains a hologram to see whether it is fake or original. So, we will see them different applications which are currently used. The first comes the ID card. As students of science and engineering, you will be all having the ID cards. So, the ID card contains a holographic pattern in the ID card. So, Opto Galileo, the identification card. So, identity card from UK, the ID card is signature, the bearer and all, which cannot be duplicated. Then comes the security applications, you know, the Visa or the ATM card. We have been going through the applications for holography. So, the security applications, as I told you, the ATM card, you see the bird here, right? You can see the colors, the diffraction grating, like so. The phenomena which are responsible for holography are what are the phenomena? You need a laser, and then the interference phenomenon, and the diffraction. You can see, you can take a Visa or MasterCard, you see at different angles, you will be seeing different colors. So, the ATM card, you have got a holographic pattern here, embossed. Important security applications are, the passport, in order that it is not stolen and misused. The very important thing in every airport, the passport is carefully seen. In very many countries, the passport contains the holographic film attached to it, and so holography plays is from Republic of Bulgaria. So, this is the passport. So, fake or genuine, that is very important. This one I showed in the last lecture. I am showing it once again to differentiate between the counterfeit note of a $100 note and this is a genuine one, right. So, the holography is able to differentiate. If you were to have a holographically made the dollar note, that is a genuine note. So, as I told you in the last lecture again, for making the hologram, the process is very costly. So, when you go to costly denominations like $100, 100 pounds, 100 euros and such higher currencies, holography is a must. It is used so that the whatever that Federal Reserve Bank note, you see the intensity when you illuminate by using a laser to be incident on the currency note, you see the difference between the genuine note and the counterfeit, and these arrows indicate, they show them differences. You see the key, the intensity of the key here and the intensity of the key here, they are different. That makes people to differentiate between the genuine currency and the counterfeit currency. And from the defense application point of view, the 3D holograms of ship you got here, the plane, the 3D holograms are again important. You can find out whether it is your plane or enemy plane. Or the 3D holograms are important. Not only that, the strains which are produced, which I will show later on, on a musical instrument or on automobile, or even when I am biting my teeth. Supposing you are eating, biting your teeth, when you are biting, the kind of the wrinkles which are formed on the forehead, or when a load is moved from one region to another region in this building, the whole structure, it undergoes stress. The stress distributions in very many CSIR laboratories. In the civil engineering department, the stress distribution, how the stress is when a heavy equipment is moved from one end of a building to other end, what happens? Structural stability and the strain that is experienced by the wall, the structure, that can be, on the side walls. These things can be observed using the holographic patterns, which I will come to it later. This is a very important thing. So, this is a sticker for the validity of the product. Whenever a commercial product comes from a market, this is a very important thing. This I should have shown at one of the very early slides. The sticker is very common, the holographic sticker, which is abundantly available, secure. This shows the genuineness of the product that is coming, and so on the product you see the sticker. The sticker is made up of hologram. This is again Nokia battery with the holographic sticker. You see the Nokia, right, holographic sticker. As I told you again, one may ask a question whether can you not make a fake hologram. As I told you, if the product is costly or millions of products are made, the manufacturers take a lot of care in making a proper hologram, which is involving very high amount of money. Therefore, this complicated process in making the original hologram cannot be reproduced by others because the cost is so high. Nokia battery with the holographic sticker, that is what you find. So, millions of batteries are made, and so the poster hologram that is being made is costly. So, this is the the object here. The whole principle is explained here. You got a laser beam splitter. One of the light beam goes to the object, the other goes to the mirror, goes here. So, the reference beam, right? These two, they interfere here, and then on the computer screen you see the three-dimensional object. This is an important medical application, whereas the intestine in the human body is its image is seen. The doctor views the image, and which portion is to be operated is carefully observed by the medical practitioner. So, the holography plays a very important role, since it has got medical applications like what I am showing here, to perform major operations, and again defense applications and very many other things. Holographic interferometry is used by researchers and industry designers to test and design many things, from tires, engines to prosthetic limbs and artificial bones and joints, right? For making artificial bones and joints, because the bones and joints also will undergo the stress. So, the stress distribution that I told you in the building, if an object is moved, if an equipment is moved from one region to another region, the stress which is acting, or the stress to which the upper wall is, the terrace is subjected to, can be seen by taking laser holograms. In the human system also, when you are biting, the dentist look at whatever that is happening on the forehead, that the biting force can be measured, the degree of the force, in dentistry. Similarly, for artificial bones and joints, in implantology, prosthetic limbs. So, you talk of total hip and total TK, or knee replacement and hip replacements, and all these places they come into the applications are found. Supermarket and department stores, scanners use holographic lens system that directs laser light on barcodes on the products. Holographic optical elements are used for navigation by airplane pilots. A holographic image of the cockpit instrument appears to float in front of the windshield. This allows the pilot to keep his eyes on the runway or the sky while reading the instruments. This feature is available in some models of automobiles also. Medical doctors can use three-dimensional holographic, this is a very important application, three-dimensional holographic CAT scans to make medical instruments without invasive surgery. This technique is also used in medical education. Holograms are used in advertisements, consumer packaging of products to attract potential buyers. Holograms have been used on covers of magazine publications. The use of holograms on credit cards, I showed you the ATM card, other identity cards and debit cards, provide added security to minimize counterfeiting. Holography has been used to make archival recordings in archaeology of valuables and or fragile museum artifacts. Sony Electronics uses holographic technology in their digital cameras. A holographic crystal is used to allow the camera to detect the edge of the subject and differentiate between it and the background. As a result, the camera is able to focus accurately in dark conditions. Holography has been used by artists to create pulsed holographic portraits as well as other works of art. Let me now pass on to the future applications, where you have the liquid crystal displays will be brighter and whiter as a result of holographic technology. So, the Polaroid Corporation has developed a holographic reflector that will reflect ambient light to produce whiter background. So, there are many other applications like night vision goggles, holographic televisions, holographic motion pictures. The future holographic motion pictures may become a reality within the next few years. And again, with regard to data storage, new optical data storage method that can store about terabyte of data in a crystal approximately the size of the sugar cube. In comparison, the current method storage includes CDs that hold 650 to 750 megabytes, whereas in the time to come 120 GB memories can be had using laser holography. Optical computers capable of delivering trillions of bits of information faster than the latest computers. Holography and musical instruments, as I told you, the strain caused on the wooden board or whatever board that you have got, the strains can be seen, and not only the strains on the musical instrument or automobiles or on the walls, as I told you, all these things can be seen using holographic techniques. So, the human eye cannot see small vibrations on an instrument. It may be, the instrument may be the kind of musical instrument I showed, or you can have automobile engine or any other component. Let me now summarize as to what I have been telling you all along in this lecture. The basic equipment needed in holography are laser, filter, recording medium. There are two types of holograms, namely transmission and reflection holograms. There are innumerable applications of holography pervading all fields. We will pass on to the question session. The questions are: what are the equipment needed for holographic technique? The question number 2, what are transmission and reflection holography? And the last question is, give some of the applications of holography. With this, we come to the end of the paper on optics intended for the BSc Honours students. Thank you.